For today's demonstration, we will use this test bench that includes an ADV200 3 kilowatt drive, 400 volt, a control box that is simulating an external operator or an external controller giving command to the drive, and all the feedbacks that are needed in order to give the status from the field to the drive itself. And an asynchronous motor, 1.5 kilowatts. And now let's proceed with the commissioning of the ADV200 drive using the WEG Express software and our laptop. In order to connect the drive to the laptop, you may use a cable that you may order from WEG that converts the RS485 interface on the drive with a USB interface you can use directly on your laptop. You may use another option that is a Modbus RTU TCP converter converting the sub-D connector directly on the drive with an RJ45 in order to connect a standard Ethernet cable. In order to perform the commissioning, we need to switch on the drive. Now, let's proceed to launch the software WEG Express from the desktop shortcut the installation created. When the software is launched for the first time, this is the screen that will appear. The software will expect the user to choose which drive the user wants to connect to. The choices are between DC converters, inverters, or lift drives. In this case, we will open the list of inverters. There are two types of ADV200 in the list. The one called ADV200 is meant to be used with asynchronous motors. The one with the S in the end is meant to be used for synchronous motors. In this case, we have an asynchronous motor, so we will go for the first choice. WEG Express uses the Modbus protocol to communicate with the drive. If you are connected through the serial interface, it will be Modbus RTU. If you're using the specific converter or one of the new communication boards for Profinet or Ethernet IP, it will communicate through Modbus TCP protocol. In this case, the drive is connected through the RS485 serial interface, so the software is automatically scanning the communication port and found the drive. As you see, the software is showing which firmware version the drive has, the address of the drive, and the baud rate. If the software is not finding the drive, you can access the advanced setting and change the communication information in order to find the drive correctly. You can also access the manual settings in order to select manually which drive the software should connect to. And you can even unclick the online mode in order to use the software offline. This may be useful to access the parameter list and all the settings and eventually configure the Modbus TCP communication. Now we will select the drive that the software found scanning the communication interface, and we will go online with it. As you can see on the bottom right corner of the window, we are now connected and we are online with the drive. We can proceed with the wizard, that is the guided configuration of the drive. The first step that the wizard is going through is the setting of the drive configuration. As you see, there are some parameters which can eventually be changed in case the mains voltage is different from 400 volt or the ambient temperature is different from what is the maximum ambient temperature the drive expects to be in, or the overload mode should be changed from heavy to light. In this case, we will leave all these settings with the standard values. Let's proceed to the second step. Moving forward, the software will ask us for the information about the motor. The rated data of the motor are shown in the picture here on the screen. We need to input the information into the wizard page. The rated voltage is correct. The rated current is 3.3. The rated speed, since the slip is 100 RPM and the nominal speed of the motor is 1,500 RPMs, it is 1,400. The frequency is correct. The number of poles, in this case the software is asking for pole pairs, is correct. We drive as 4 poles. The rated power is correct, but the power factor must be changed. As you see, the software is showing that these parameters have been changed from default, since they are now in red. Let's move to the next step. The next step is the AUTOTUNE procedure. We can perform the AUTOTUNE rotating the shaft of the motor, or in case the load is already connected to the motor, we should go for the AUTOTUNE still, that is measuring information from the motor without moving it. Since we don't have any load connected, we will go for the AUTOTUNE rotation. As soon as we try to start the AUTOTUNE process, the software will inform us that we need to close the enable hardware to the drive in order to proceed. As you may remember, the digital input 7 is the enable hardware that has to be closed before moving the motor. Let's do that. Now we can proceed. While the AUTOTUNE is proceeding, the software will show us the progress in the progress bar. During this procedure, the drive is turning the motor shaft, measuring the electrical data that will be populated in the screen as soon as the process will be over. Now the progress bar has reached 100% and the correct values have been calculated. We can move to the next step. The software is remembering that the drive is still enabled, so before proceeding, we need to open the digital input 7 to the drive. In this screen, we can set the regulation mode of the drive. The default value is voltage on frequency, but it can be changed to vector control, open loop, or closed loop. We will leave it to the default value, voltage on frequency. The next page is showing the speed limits, high and low, the overspeed threshold, and the full scale speed, that is, the value of the motor speed in RPMs corresponding to the 100% of the scale. We will leave this value to the default values. The next page is used to decide the source of the speed set point. Again, we will leave it to the standard value so that eventually we can provide the speed reference through the analog input 1 connected in the control box to a potentiometer. Let's move to the next step. In the screen, we can change the acceleration and deceleration time of the drive so the changes to the reference that we can set. We will skip the motor potentiometer settings since we are not using it, as well as the jog function. In this page, we can enable the overload to the motor with the values that we see here in the same page. We will leave it to default. Moving forward, we can inform the drive that we are going to use a braking resistor for dissipating the regenerative energy that may come back from the motor to the drive in case of fast braking of the motor or high inertial load. This was the last setting. Now we suggest you to save the parameters in order to ensure they are not lost in case of a power loss or when you switch off the drive. The parameters have been successfully saved. Now that we have completed the initial setup of the drive, we can test if the motor is running correctly and the drive has been configured in the right way. To do that, we can use some software tool that WEG experts have and are very useful for this purpose. In particular, the control panel, which is a simulator of digital inputs and analog inputs to the drive, and the graphical window, where we can view in a graphical way how different values are changing. In particular, we want to observe the output current. As you see, we can just drag and drop the information into the window. We will have a look at the speed set point, the motor speed, and the state of the enable command. We want to see all the values. In order to use the control panel, we need to enable it. Now we can give command to the drive. As you may remember, the digital input E is an hardware enable. So before moving forward, we need to give it in a hardware way to the drive, closing the terminal 7. Now we can simulate the digital input 1 with the software control panel in order to give the drive enable, and we can change the speed reference as you can see in the graphical window. We are adjusting the view in order to see the value for a longer time, so it's easy to detect the change of the enable signal and the moment we are applying the speed reference to the drive and the motor is turning. We can take off the enable and the drive will stop. We are now going to remove the enable hardware. And we can remove the enable to the control panel. We have reached the end of this tutorial about the commissioning of ADV200 AC drive. Please consider that all the information about the installation and parameterization of the drive may be found on the manuals you may download from the WEG website. Thank you for watching this video and stay tuned for more videos to come.